Hi, I want to make a short video this week to get you started in week one. So let me go ahead and share my screen real quick. All right, so here I am on the course, right, which is in Canvas. So if you go to the Canvas tab on the portal, click on Log On to Canvas, you should see this CNET52, right? So let's go into there. And I just want to kind of give you the layout of the course. So you can read about the information here. Here's a quick video from YouTube about what are operating systems in real general terms. But the meat of the course is going to be on the modules. So if you click on the modules, there's some information to get you oriented towards Canvas. There's an Ask the Professor forum. So if you have any questions, you can just pop into here and ask. It'd be the same thing as raising your hand in class and saying, hey, how do I, well, since we're online, we can do it there in the Ask the Professor forum. The introduce yourself, which almost all of you have already done that. If you haven't, do that before Thursday. And then the syllabus quiz, which you have to do as well. And then here's, if you want to meet with me on Zoom, just click on this Zoom with the professor. All right. And then every week there's going to be a discussion. And the discussion for this week is your first uses of a computer, what operating system, what were the reasons you started using it. So you want to answer these prompts, these 3 prompts by Wednesday at 11:59 p.m. and then respond to 2 of your peers by Sunday at 11:59 p.m. All right, and then that is worth 10 points. Okay, so that's due every week, and then each week there will also be a quiz. So the quiz will just be on Canvas. It's available from August 22nd at 12 a.m., which was Monday morning, until the 28th, which is Sunday night at 11:59 p.m. There's 10 questions. You can take it one time. All right. And then every week, I will also have a PowerPoint, which I'm going to go through this real quick in just a minute. But the labs, and I'm going to explain the labs in more detail on Thursday. So be sure to show up on Thursday. The labs are in person. You have to show up on that first week, otherwise you'll get dropped for no show. So make sure you show up tomorrow at 6:30 p.m. in room 404. All right, so let's talk about the PowerPoint. All right, so the PowerPoint, I'm gonna make this full screen, is going to just go through and do a basic introduction of what is an operating system. So a computer really has 3 tasks. 1, it takes data in. 2, it processes the data and then it outputs it. So in real basic terms, it says, hey, give me some information. Let me do something to it. Let me give it back, right? So whether the input is through the keyboard or through the network or through a microphone or, you know, through a video card, whatever the input is, the computer will then process it and output it into another format or where it's more usable. All right. Now, the computer itself is based on hardware. And there's another course that we teach called CNET52, where we introduce you to computer hardware. So if some of the hardware stuff is you're not super confident in right now, yeah, I'd recommend you sign up for one of the available sections in CNET50, which there are still some openings in several. We have 3 different courses. All right. So the hardware, but the hardware by itself doesn't do anything. It needs software to instruct it, to give it kind of its marching orders to do stuff. And that's what the operating system is. And in this course, we're going to investigate the 3 main operating systems, which are Microsoft Windows, and we're going to focus on Windows 10, and then CentOS, which is a distribution of Linux, and we'll look at version 9 of that. And then the Mac OS 10, which we're going to do 10.13. All right. So the hardware is similar in almost all those machines, but the operating system is totally different. As you'll see in this week's lab, and then every lab going forward, how do you do something in Windows is a little bit different than how you do it in Mac and how you do it in Linux. So we'll get to that. All right. So what does the operating system do? Well, it does a couple of different things. One, it is how does the user interact with the system? So for example, on my computer with Windows 11, I have the graphical user interface, right? I can see, Excel, PowerPoint, my calendar, whatever it is. And there's also a command line interface. So here I can, type commands to get information that will show me various things. So if I do ls-a, and some of these commands, I'm on the Windows terminal, which I don't know if you've looked into that, but it's like the shell for Linux, but it's in Windows. So I have that on my computer, but some of the commands are a little bit different. So we give it a user interface, which is both GUI, graphical user interface, and then command line interface. It manages our files, and then it processes and manages the services. So a process is a program that's loaded into memory and run by the CPU. So if I look at my task manager, which is in Windows, this is how I see what's going on, processes. So like on my computer, I have Google Chrome open, right? Malwarebytes is running, Outlook, Task Manager is running, and then Zoom is running. And then there's some stuff going on in the background as well. So those are processes. And the operating system is going to also look at and work with our memory and our input output. So the OS will say, okay, Word, you want to run, I'm going to give you 700 kilobytes of RAM. And then Word will open and say, I need more memory. The operating system will say, okay, here's more memory. And then when Word finishes, or if it stops, we'd stop using it for a minute, it will give back that memory to the operating system. So the operating system basically is handing out resources as the system needs it. Now, obviously, there's a finite or limited amount of resources. So for example, I cannot run a piece of software that needs more memory than my system has. So if I have 8 gigabytes of RAM and I need 12, the operating system is not going to be able to perform that very well, right? It may be able to run that software, but it's going to be painfully slow. And you probably all run into that situation on your own computer where maybe you have too many tabs open on browsers or too many games running at the same time. And all of a sudden your computer gets in this slow down mode, right? Everything goes really, really almost painfully slow. So that's where the operating system is trying to handle that. Okay, another thing the OS will do is it will handle the security, and it will attempt to protect certain resources from malicious activity. So for example, the CPU will have code built into the CPU cache, right, where it has information about the processor, and it will prevent certain activities from happening. So even if there's some malicious software out there that says, hey, turn on these registers and fill them with data that's just kind of bogus data to cause it to slow down, the operating system will prevent that. It will say, no, you don't have the right permissions to get to the CPU, all right? And then the biggest part, and probably the main part of an operating system, is the kernel. And the kernel is known as the heart. So here it says the kernel is the heart of the OS and runs with this highest priority. So in Windows, so let me open the command prompt again. Where'd that go? All right, so here's my terminal. So in Windows, if I list okay, I'm gonna have to look up how to show that in Windows. In Linux, you can do list process, but it will show the kernel, which in Windows is called the nt-kernel.exe. All right, and that's really when we say Windows 10 or Windows 11 or Windows 8 or whatever version we're talking about, we're really referring to the kernel. Because if you look at Notepad in Windows 7 or Internet Explorer in Windows 10 or Microsoft Word that you had on Windows 8 or Windows 11, those applications are the same, but the kernel is what has changed. Right, so there's some categories of operating systems. I'm going to leave some of this for you to read, but single tasking means it can only do one thing, and then it stops and does another thing, whereas multitasking means it can do multiple things at the same time. A single user operating system means only one user can log on and use it at a time, whereas a multi-user, you can have multiple users. Right? Like in Windows 11, I can come in and I can switch users. So if I come into my user here, I can click on the user and then change account settings. So I can switch users if I want to. So that's a multi-user. And then there's general purpose versus real time. Most modern operating systems are multitasking, multi-user, and general purpose operating systems. All right. So here's a single tasking operating system. Early versions of Apple and MS-DOS were single tasking. And then multitasking can do two things at this, or more than one thing at the same time. And there's two general types of multitasking, cooperative and preemptive. In cooperative, the operating system will give control to the CPU. The CPU does what it wants, and when it's done, it gives it back to the operating system. Then the operating system gives it back to the CPU, can do something else. So the problem with single tap or cooperative multitasking is if, say I open Microsoft Word and Word hangs up, it gets stuck, right? Where it's not responsive. Well, I can't get back to the operating system because this has it locked up. So with cooperative multitasking, if something froze up or had a bug or some sort of security flaw, the whole operating system was problematic. So you had to give it back. And so no other program could run until that system was taken care of. Well, to fix that, they came up with preemptive multitasking. And now with preemptive multitasking, the OS says, okay, you want to run Word? No problem. I'm going to give you some resources, but I'm not going to give you full control. So you can run Word over here, and then something else pops up, says, you want to run Chrome? I'll give you control for a little while. So the CPU or the operating system's always in control. And that's where we get Task Manager, where we can end a task. Let's say Word freezes up on us. We can stop Word and it will end without having to restart the whole computer. All right. So like, for example, user can play music while working in documents and web browsers. So here's a little graphic that shows with cooperative, the process one has to go and run. Is it finished? Yes, goes back to the CPU, then process two starts, and then it goes, and then process three, and it keeps repeating, right? Whereas with preemptive, it says, okay, process one, the operating system gives you some of CPU. Whether this is running or not, it can say process two, you can run, and process 3, you can run at the same time. All right. And then here's talking about single user, multi-user, general purpose, and real time. So I'm going to let you read some of those slides for yourself. And by the way, the book for this course, let me get to show you that real quick, because that's important too. So the textbook for this class is this ISBN 978, and let me just search for that. And if you go to Amazon, you can find it. And we're using the 6th edition, right? So this is the 6th edition. And the textbook, even though it's not required for this course, it is going to help you understand more about this information. So not everything is going to be in these PowerPoints. So you'll want to make sure you get a copy of the book, or otherwise you're going to have to do other research to find some of this information, especially on the quizzes. All right. So there's some more information in here about operating system roles with the client, server, standalone, and then some of the components. Right. So I'm going to stop this video for this week here, and that was just to get you started on this week. All right. So I will see you on Thursday in the lab. If you have any questions or comments, be sure to bring those to my attention. We will do lab 1 this week in our lab time. So I look forward to that, and I'll talk to you later. All right. Bye.